Sorry for the interruption. We have discussed problem 1, this problem, and now we had started this other problem where you have to find alpha, beta, and gamma. There's different ways to find this, but the first thing you have to do is to make sure you understand what the drawing has. And as I mentioned earlier, you have your let me make sure you have your components in X, Z, and Y. Alpha in this case is 29. So what I want to do is let me use a different color to show different things we have going here. So this line here is what we would call f prime, which is the projection of the vector. And so the first thing we have, well, we have several issues here. So fz is going to be f times sine of zeta. Fx is going to be, well, let me go to f prime is going to be equal to f cosine of zeta. So now fx would be f prime times sine, in this case, of 45. And then fy is going to be f prime times cosine of 45. Okay? So in other words, it would be equal to f sine zeta sine of 45, or f sine zeta sine of 45 degrees. Okay? So you have your x, y, z. Now why do I do the fyz? Well, fx over f would be the cosine of alpha. Fy over f would be the cosine of beta, and fc over f would be the cosine of gamma. Now the other thing that you need to keep into account is also the cosine square of alpha plus the cosine squared of beta plus the cosine square of gamma equals 1. Now the other thing that I want you to take a look at, which is important, and we had some problems like this in the homework. Okay, so let me change the color here to show something else. So let me use the yellow this time. So what is alpha, beta, and gamma? Well, this would be alpha. Use a different color. This would be alpha, and from here to here would be beta. But then I know, look at this, gamma. So I know that alpha and beta are going to be less than 90 degrees, but gamma is going to be larger than 90 degrees. And this is important because whenever you calculate sine and cosine, sometimes you can have two different answers, and that's the case here. Okay, so having said that, let's calculate the cosine of the fc first to calculate the gamma first. So f z is going to be equal to f sine of 29, and this is going to be 36.36, so that now fz over f let me leave it in red, like f, oops, Fz over F is going to be cosine of gamma. So that's 36.36 divided by 75. So in this case, gamma would be either, let's calculate that real quick. (61 degrees) or 119 degrees. This is 180 minus 61. So, and I know that in this case it has to be 119 because it's larger than 90 degrees. Okay, so then Fy over F, it's cosine of beta, which is, I need to calculate Fy, and I have to calculate F prime, so let's have it here. Okay, so I have F sine of 29 times sine of 45 degrees, and this here is 75. So here I have 46.4. Okay, so you can either calculate what's F prime, like here you have it 75 times cosine of 29, which is 65.6, or go directly and calculate this. It's 45 degrees. That's 45 degrees. So what I have here is that beta is 51.8 degrees, and then Fx over F would be cosine of alpha, which would be, if I look here, F sine of theta times Fx sine, I think I have, this is cosine. This is cosine here, sorry. And this is sine of 45. But for 45 is the same number, sine or cosine, so alpha equals also 51.8 degrees. Okay? If you have any questions, let me know. But this is it. So now we have another problem. We have a bolt subjected to a force F with components, and then this is what I told you, that this was Fz. So let's write what we have here. Given 86 newtons, alpha equals 60, gamma equals 50, Fx equals 43 newtons, and Fz equals 55 newtons. So we can do this in different ways, but one easy way would be to look at alpha and gamma, and you know that alpha plus the cosine square of beta plus the cosine square of gamma equals 1. And so we have alpha is 60, gamma is so we have cosine square of beta equals 1 minus square of gamma minus square of, okay, and so this would be 1 minus 0.5 squared minus 0.64 squared, which is 0.34. So beta equals 54.5 degrees. So now having beta, here I have my beta, so I know that this is going to be more than 90 degrees. Oops. So 180 minus 54.5, so this is 125.5 degrees. So anyway, now you can calculate Fy over F equals cosine of beta. So Fy would be F cosine of beta. And this is 50 newtons. If you use 54.5, you would get a positive number. Now you know that this component y goes to the left, and that's why you would, if you use 54.5, then use a negative. If not, you have here a negative 50 newtons. Okay. So this next problem is to determine the magnitude of the projected component of the force, and I'm telling you what is the force equals 450I minus 250J plus 650K. So this is the component, and so it's I'm asking about the force along cable BA, so I'm referring to that position RBA, which would be A minus B. Okay, so here we have, let me write down here the component 0, 0, and for B 0, minus 1, and 2. Okay, so what I need to make sure is I have from A to B, I have 6 minus 0 I plus 0 plus 1 minus J plus 0 minus 2 K, so it would be 6I plus 1J minus 2K. But this is the vector BA. I need the unit vector in that direction, which then would be 6I plus 1J minus 2K divided by the magnitude squared plus 2 squared. Okay, so let me get this number. So this would be 6I plus 1J minus 2K divided by the square root of 41. I'm going to leave it expressed like that. So then what I have is that the force along BA, I'm asking for the magnitude in this case, would be F dot UAB. So it would be 450 times 6 over square root of 41 plus 250 1 over square root of 41 plus 650 negative 2 over 41. So this would be 180 newtons. This next problem is a multiple choice, very similar, but then instead of a dot product, what we have is basic multiplication. And I already gave you the force, which is 70 pounds, and this cord that he's pulling, this is from A to B. Okay, so what we have is the position vector. I already gave it to you, minus h 8h 24k. So what we have is the unit vector in that direction is 12i minus 8j minus 24k divided by the magnitude. So let me recalculate this. I have 12 squared plus 24 squared. So what we have is AB equals I minus J minus 24k, and this is divided by 48.7. Okay, so then the force in this case is the force from A to B, and then I multiply times the unit vector. Sorry, let me put it differently. So this would be the magnitude of that force times the unit vector in that direction. So it would be 70 pounds times 12i minus 8j minus 24k divided by 48.7. So one thing you can see is that you have negative and negative. And then positive at the beginning, so you cannot eliminate anything. But then the result of this should be 30i minus 20j minus 60k. And this is the force was given in pounds. Okay. Finally, this is the bonus problem, and basically what you need to remember here is that this is the force that we're looking at. So it says determine the unstretched length of dB to hold the 40 kilogram crate in position. So this crate is 40 kilograms, so the weight would be 40 kilograms times 9.8 meters second square, so that gives me 392 meters. Okay, and there's several ways to solve this. I'll just solve it in one way and make sure that you know alternative ways of showing this. So let me look up these dimensions here. So this is 2 meters and this is 3 meters. This is 2 meters, And so what I can see is that then the length here is, this is 2, 2, and then this would be the square root of 8. And then if I look at here, would be the square root of 13. So I can look at this in two different ways. Just deal with this as if it was the slope. It can be simplified, but you can use it directly like that. So whenever we look at this, this is really the stretched length, okay? But we know that regardless, this force, and let me change the color again, the force of the spring is what we're saying, that it's FB, and that equals K times S, okay? So we'll find S and then determine the unstretched length. But for that I have to do a system of equations in this case. So I'll look at the sum of the forces in X, and this is in equilibrium, equals 0, and then this is my positive notation. So as I said, I'm going to use these values as slopes as well. So I have FB multiplied times 2 square root of 13 minus FC, and then I have 2 divided by the square root of 8 equals 0. So I have this 2 unknowns, so I need 2 equations, and I'm going to do sum of the forces in Y equals 0. So in Y I have FB it's 2/13 too, because it's 2 and 2, plus FC 3 over square root of 8 minus 392 equals 0. So I have my other expression. So what I'm going to do is go to equation 1 and express, for example, I can do it anyway, but express FB as a function of FC, and then substitute in the sum of the forces in Y. So I'm going to do this first. I have FB 2 divided by 13 equals FC 2. Okay, so FB equals FC 13 divided by the square root of 8. So what I'm going to do is substitute this expression in number 2. So now I go to number 2, and then I have FC 13 over 8, and remember what I'm doing is now this expression is this here based on this change, and then it's multiplied times 2 square root of 13 plus I have FC 3 square root of 8, and this equals 392 newtons. So I do this, this cancels, so I have FC, and then I have 5 divided by square root of 8 equals 392. So FC equals 221.75 newtons, and then I go to 1 again, and then calculate FB, which is FC. Now I could have calculated directly the FB. I just wanted you to see how the different ways we can do it. So FB equals 2 to 1.75, 13/8, and this gives me 282.68 newtons. Okay. So before I move to the next slide, this here would be the the length of the stretched spring. Okay. So let's go to this. So remember that then my FB is 282.68 newtons. Okay, and FB, which is with the spring, equals K times S, which is the stretched, which the K is given here, which is 160. So that means that 282.68 newtons equals 160 newtons per meter times the stretch. Okay, so this will give me a value for the stretch. Let me calculate it again. I had it somewhere here. So the stretch equals 1.77 meters. Now remember, the stretched and equals the L, the original, minus the stretched length. Okay, and I don't know the original, which is the unstretched, but I know the stretched from figure. This was square root of 13, which is 3.6 meters. So the stretch equals L0 minus L, the stretch being 1.77 meters equals L0 minus let me see. Oops. Let me erase this. So the stretch is 1.77. Sorry, I have it this backwards. I should have looked at the equations. Let me, it's backwards. I have it backwards because the stretch is longer. Apologize for that. So you have the stretched minus the 0. I didn't want to use the equation because the book uses a different notation. So the stretched is from figure 3.6. So from the figure provided, which is 3.6 meters. And so let me erase this. So the generic form is that the stretch, which is normally longer for springs, would be larger than the unstretched. So this was 3.6 minus the unstretched. Okay, so this is the unstretched. So then the stretched would be 1.84 meters. And that's it. If you have any questions or need some clarification in some of the problems, let me know. It took a little longer just because I was explaining the steps, but I hope this is helpful. Thank you.